So you've got the circuit diagram. You're told that there are 12 volts over the battery, and you are then told that there are 4 volts being used by the first resistor in series. I'm just going to do the colors thing, where I go along until I hit a resistor, and I go along until I hit a resistor, and I go along until I hit a resistor, and until I hit a resistor. What you can quite clearly see from that is that this section is in parallel, whilst that resistor is in series. So they're left with 12 volts. They have spent 4 volts at this resistor. The electrons have got left 8 volts to spend at each of those ones. They're in parallel, so it's a choice. Either the electrons go through the top or they go through the bottom. So it is going to be, the reading on both of those is going to be 8 volts. Then determine the reading on A3. A3, the electrons come along 3 amps. 1 amp goes to the bottom, meaning that there are 2 amps left for the ammeter over there. Then they want to know the resistance. So you actually now need to do a calculation. And if we're looking at R1, the potential difference over R1 is 8. The current going through R1 is 2, so I land up with 4 ohms. And for resistor 2, my potential difference is 8. The current going through there is 1, so it's going to land up being 8 ohms. Looking at the next diagram, we are expected to determine the resistance of, the voltmeter and resistors and all of that sort of thing. This time, interestingly enough, I am not given the potential difference of this battery. I'm not even told that it's 2 volts each. What I am told, and again let's do our colors, go along until you hit a resistor, go along until you hit a resistor, come from the other side until you hit a resistor, and you can quite clearly see you've got a parallel section here and a series section here. The series section uses 2 volts. The parallel section, the whole of that branch uses 6 volts. So altogether there are 8 volts coming from the battery. There are also 4 amps on the main branch of the circuit. And if I now go, what is R3? R is equal to V 2 volts over 4 amps in the series circuit, and that's 0,5 ohms. If I take a look now at the other voltmeters over here, I've got 6 volts on that branch. That means I must have 6 volts used on this branch, but there are 2 resistors in series. The one uses 2 volts, meaning the other one must use 4 volts. I can now say I know the current in this little section over here. I is equal to V over R. For that particular resistor, the potential difference is 4. The resistance is 2, so I get 2 amps. I know now that the bottom is 2 amps, which means that the top must be 4, the main branch minus the side branch, and that is also going to be 2 amps. And finally, calculating R1, potential difference 2 divided by the current on that branch 2, and I land up with 1 ohm. So the reading on voltmeter number 1 was equal to 8 volts. On voltmeter number 2, it was equal to 4 volts. On voltmeter, no other voltmeters. Ammeter number 1, it was 4 amps. Ammeter number 2 was 2 amps going through that bottom branch, and again through the top branch 2 amps. Resistor number 1 is 2 ohms. I'm lying again. Resistor number 1 has got 2 amps flowing through it and 2 volts. It has a resistance of 1 ohm. Resistor number 2 is on the top branch. It's 6 ohms divided by 2 amps, so it is going to have 3 ohms. And what is the resistance of resistor number 3? It was 0,5 ohms. In this circuit, you're given that V1 is 6 volts and that V2 is going to be equal to 4 volts, and the ammeter is 1 amp. We can work out everything else quickly, and we can say that that must be 2 volts on voltmeter number 3. So when they say that voltmeter number 3 is 4 volts, that's false. Then you've got resistor number 1 must be 4 divided by 1, because it's a series circuit, so it should be 4 ohms. that is true. And resistor number 2 is equal to the 2 volts divided by the 1 amp, which is 2 ohms, and that is therefore false.